Thank you. Yeah, I remember this one. So I'm going to get started. So first of all, thank you so much for all the hosts of the Groundbreakers EMEA Tour for organizing this amazing event. I'm just the first speaker and I'm not the last. And there are going to be a lot of cool speakers coming after me that are going to constantly bombard you with a whole bunch of information, knowledge. This is going to be a very good opportunity for you to learn as much as you can. I had the opportunity last year to participate as part of this EMEA tour, and I met some of the most amazing people and some of the most coolest speakers covering some of the most amazing topics that I learned a lot myself during this tour. So I'm thinking that this time there are going to be way more speakers because of the ability to present remotely, and this is going to be a very, very interesting tour. Please take advantage of this. The organizers have spent a lot of time trying to bring this together. It started. I'm the first and I'm the last. I always start. I started the AIOUG tour as well. My name is Sandesh Rao. I've been in Oracle for almost 20 years. My background is basically databases, but I've also done a lot of AI or AI ops related stuff for the last couple of years. And my topic today was an introduction to machine learning and how DBAs can basically move to becoming data scientists. Now, some of you have probably seen my presentation before. I have done this, but I always like to keep things simple. I explain concepts in such a way that once my session is done, for you, it's extremely easy for you to just take this thing and get started on it. So that's the most important thing, is your ability to pick this content up and start learning and start utilizing this as part of your job. First question everybody asks me is, where can I get this presentation? So take a picture of this slide, and also this will be available after the OGB EMEA tour is done. This will also be uploaded to their site. But my LinkedIn and my SlideShare are usually where you will find this presentation. And please feel free to follow me or send me questions on Twitter at Sandesh Rao. All right, with this, we get started. So traditionally, what DBAs are responsible for is architecturing, modeling, data security, lifecycle management, backups, HA, patching, provisioning, configuring infrastructure, as well as database optimization. But what's happened in the last couple of years is a lot of the tasks that involve configuration management, patching, provisioning have all slowly being automated, especially as part of the autonomous database initiatives, right? Generally there seems to be more and more of a trend towards this, where there's more focus on architecture, planning, modeling, data security, cybersecurity, and any kind of end-to-end service level management. So these are like more higher value tasks today as per the business. And most of us as DBAs have kind of had a slightly rough patch in trying to understand, okay, what is my role now? What am I supposed to do? And I told some people that there's this new thing called machine learning, which is basically a set of tools that you can utilize for making your job a lot more interesting, and utilizing these tools to be able to process this data to be able to give more better insight to your business. So there are a couple of new roles that have come up recently, and one of them is basically a data engineer. The second one is basically a guy who works on all these machine learning problems. Now, there's a difference between these two roles. The data engineer role is basically a guy who takes content and organizes the content, cleans it, makes it available to somebody who then a data scientist will come along and take this content and start playing with it. And that's the machine learning part of it. So there's two roles: the person who gets the data required for the data scientist, and then the second one is the actual data scientist who actually uses this data. Now, both of these roles are extremely important, as we will see going forward, and how these roles kind of play with each other. I'll go into this in the subsequent slide here. So data extraction and data wrangling is not something that is new. Most people as DBAs have already done this as part of traditional data warehouse and ETL kind of jobs. When you do data extraction, you're basically pulling out a certain set of attributes out of this data. You're doing something called feature engineering. I'll go into these terms as we go through the presentation, because it's very important if you are transitioning as a database developer or as a DBA to a data scientist role, you should know all these terms. Majority of the work is always in the data extraction, wrangling, and the feature generation. That's typically 80% of any machine learning project. The smaller part of it is to basically import predictions, insights, deploying models, running all this auto ML processing on top of this data, and then trying to come up with a proper model. That's usually less than 20% of the work. So remember, the most amount of time is actually spent in finding, cleaning, and organizing this data, which is actually most important, or the most important part of a machine learning project or a strategy. So one thing that I've always seen is whenever I'm talking to any customer, or I'm working with somebody internally also who's working on these models, the first thing that lands up happening is people are trying to solve the problem. You have to think about what the problem is and what are the various aspects of the problems that you need to solve before you start writing algorithms to solve this, or before you're writing code to solve this problem. The biggest problem in any of these machine learning projects, and that matter any project, is people try to fix and provide a solution for a problem without actually having to spend time thinking through the problem itself. This is a very trivial statement, but it's also an extremely important statement that people do not spend enough time on. So any machine learning project that you would work on, you start thinking of what kind of data do you need to get? Where are you going to get this stream of data constantly? What are the volumes of the data? What does this platform need to scale? Who are the users that are going to consume this information? What level of filtration needs to be done on top of the data before the user is ready to consume this information? What is the lifetime retention of this data? You see, I just gave you so many questions, and all these questions are problems that you have to think of as to how to handle a project before you actually start saying, oh, I'm going to run this machine learning algorithm, I'm going to do this model, I'm going to run this test and tuning set on this, and then this is what's going to happen to it. So always remember this: any project you think of, spend more time thinking about the problem and what you're going to do to this problem, rather than trying to spend about the time trying to figure out how to solve this problem. Because solving the problem is actually the easiest part. Coming up with a proper architecture, a proper model with the proper features, and then trying to train your model correctly is the most important aspect of a machine learning project. Why is machine learning very important? Spend a few seconds on this. First of all, we're generating too much data. We don't have time to do this manually. Most of the software already does the heavy lifting for us. So people who have no ideas of what machine learning is and have no coding related experience can basically get into this stuff. CI/CD, or continuous integration and continuous delivery, which is a process that is used in DevOps for writing code, for testing it, for shipping it, for doing A/B testing, and then pulling it back and trying to figure out if this thing properly worked with a customer or not, is available for MLOps. MLOps is the process of trying to do model generation, model testing, without actually having to do the entire process manually. So there's a lot of infrastructure for continuous integration, continuous delivery that's already available for MLOps. And obviously, the most important thing that people focus on is the algorithm. And you don't really need to know what the algorithm is. You just need to know it's there, and it's a tool that you need to use when you're trying to build a machine learning model. The thing that you need to spend your most amount of time on is to find the use cases that you have that will give you the maximum impact. So basically, you want to make your boss happy, and your boss has to pay you a lot of money every year. And in order to do that, you have to find the use cases that he or she is troubled with, and then you basically work on those use cases. So that's the most important thing that you have to pay attention to. What's happened over the years? Reports and dashboards. Everybody likes reports and dashboards. Then we went into more diagnostic analysis. Oh, why did this happen? I want the answer now. I don't want to spend 1 week doing postmortem analysis. Then we went to machine learning and predictive analytics. What will happen if this happens? And then we went to machine learning applications. Machine learning applications expands the scope of what will happen. What will happen if this happens? And if this happens, will that also happen? And who will I have to inform? Who will actually be impacted by this? There are going to be a whole bunch of additional questions that are going to show up as part of this ML-enabled applications. So you can see the flow. We have moved from data to information, to predictions and insights to machine learning applications. That's where we are today in our regular IT processes. Now, what are the various steps that we need to go through in order to become a data scientist? So first of all, we already spent understanding the business. This is the use case. Then we have to understand the data. Once we understand the data, then we have to basically organize and prepare this data so it can be consumed by the model. And then we evaluate how successful this thing is with the model, and then you deploy it. These are the various steps that anybody has to go through when you're building a machine learning project. A little bit more details. Once you have the business objectives and you've gathered and you've compared and you've cleaned the data, then you identify the features from this data. The features or the attributes are basically the columns of the table that you're trying to analyze. These features or columns are basically the columns that you select are going to give you the answers that your machine learning model is trying to find the answers for. For example, if I'm trying to sell insurance, I want to find out how much money this person makes, and how many times have they claimed insurance from somebody else? How many accidents have they had? And is their household having any people that are under the age of 18 that might actually be a risk for the insurance company? So these are the important columns that I need to determine if this person should be sold insurance or not. So this is basically called feature extraction. This process is called feature extraction. And this helps us identify the efficiency of an algorithm. Then you take the actual data itself. Now the actual data is split. Now the split usually is random. And this, say for example, if I have 100 rows and I split this data into test data and to training data. So I take 40 rows here and I take 60 rows there and I make it into the test and the training data. I have applied a random function to split this data in such a way that I'm trying to provide a good sample set of what the application will basically have to see when it's actually applying the algorithms to it. The process of taking the training data with the algorithm and training the model and then applying the testing data to it to see how well it picks and understands, that measurement is what determines the success of a machine learning model. Now, in order to pick this properly, it's also important to pick the right value for the hyperparameters. So what's a hyperparameter? A hyperparameter is an input to an algorithm. So what an init.ora is for an Oracle database, when you start it up, you have all these parameters. A hyperparameter are algorithm inputs, input parameters that you have to specify depending on what kind of algorithms it is. If you're using random forests, then you have to specify the number of forests. So depending on the algorithm that you use, you will specify how many, what are the values of these particular attributes. Once you combine all this together, you get a model. And the model is what is applied on production data to do whatever that you want it to do. In this case, I'm trying to find the people that I should sell insurance to that most likely will not claim anything. So I'll make more money. And these people will never claim any insurance. That's what this algorithm is designed. So I'll quickly go through the terms, recapping in this slide that I went through. First, the features or attributes. These are the input columns of the table that are going to be passed to the algorithm to determine the outcome. In this case, is to sell the insurance to this particular person. The second thing is the test and the training data, which is basically the data set that's going to be taken. The training data is what is used along with the algorithm to build a model that is going to predict the outcome of this insurance problem. The testing data will test the efficiency of this model. In other words, it's like you go to a test and you see how many grades you get. And if you get a good grade, that means your training data was representative of what your problem is. Otherwise, if you get a bad grade, maybe your training data was not accurate. There are two more terms here that I need to mention. If you go to an exam and the exam has the exact same questions that you studied in your book, then you come back with great grades. Now this is called overfitting. You basically overfit the problem. When you go to an exam and say the questions that come you've never seen before and you basically fail the exam, then this is called underfitting a problem. The good model should neither overfit nor underfit. It should be somewhere in between. And in order to do this, the process is called regularization. Regularization is the process of massaging input data using algorithms called n-fold cross-validation. Forget the terms, just understand the concept. Think of it as I'm making a cookie and I have to take the dough, and the dough has to be mixed correctly for the cookie to be tasty, and the chocolate chip chunks on it to not melt or look funny. So I'm trying to make a good cookie. And all of these are just input ingredients to make the cookie really good. So test data, training data, input attributes, overfitting, underfitting, hyperparameters, and the model itself. This is a flow of a typical ML project. Four major categories of machine learning that at least we play with. There are many more categories than this, but these are the most important that will cover everything. Supervised learning is a regular expert system where the system does what it's told to do. Semi-supervised machine learning is where the system does about 80% of the decisions. And as a user, you train the system to basically correct decisions that it has made that may or may not be accurate. So that's why semi, because there are human experts involved. Unsupervised learning is a method to find patterns from input data where a human doesn't know what to do with this data, and you're going to ask the algorithm to detect these patterns from this data. And then reinforcement learning, which is basically taking decisions on past kind of reward for these actions. It's a very common set of algorithms used for gaming and game-related training. And there's queuing models, there's DQ models, there's a whole bunch of new algorithms in this space. But it is also used to predict system failure related scenarios. So reinforcement learning is another category. I wanted to quickly cover this because this is most data that comes in IT-based systems is in the form of a time series analysis. And you're doing any kind of forecasting, seasonality, which means something happens repeatedly over a period of time. The seasonality of an AWR is 24 hours. The seasonality when I have coffee is twice a day, one in the morning, one in the afternoon. So seasonality is how predictably something is going to happen and repeats the same sequence of actions over a fixed period of time. So this is all part of the time series analysis. In machine learning, there are a couple of important terms. There's classification. These are three different algorithm categories. There's classifications, there's regressions, there's clustering, which contain most of the common problems that you will need to solve, that you would not have to even bother going into neural networks for this. So the attribute importance is what I told you is what you will use to identify the most important columns of the table that are going to be input to this particular model. Classification is where you're trying to predict customer behavior, or you're trying to target something. You bought this dress and hence you might probably like these other dresses. These are classification kind of problems. So anything you buy on your Amazon cart is a classification problem. A regression, you predict or regress a value. Oh, this stock is going to go down because of this event. So anything to do with a number, you can actually estimate or figure out its regression pattern. You're segmenting a population. Which users like butterscotch ice cream? In this particular area, if I sell cookies, how many people are going to buy it? So you try to segment a population based on something you're trying to sell, based on an important characteristic. And then if you want to find fraudulent events or rare events, you use a method called anomaly detection. Understand these terms because these terms will come up again and again when you're going through various kinds of machine learning models. And then you try to determine anything that's co-occurring with items in a basket, which is also called as set associations. That's another category of algorithms. So these are the most important algorithms categories that you need to know and that you will run into. And if you use this, you can, most of the use cases, you can play with just these categories. So the breakup here is these are supervised learning and these are unsupervised learning. Now, when someone tells you, hey, have you applied support vector machines, or are you using a lasso or ridge regression for this problem? They're basically talking about the algorithms. These are the algorithms that come under the categories of all the various sections that I have spoken about. Now, you don't have to know what these algorithms are, and they usually have extremely complicated names, but that doesn't mean that you need to know what they are. You just need to know which one to use for what kind of a problem. So they have different problems have different algorithms, and you will realize this after you start playing with this more and more, where you'll be like, SVMs are good for this kind of problem. decision trees are good for this other kind of problem. As you play with more and more projects, you will realize which algorithms work for what sort of problems. The reason I put this slide is I've outlined some of these algorithms and I've mapped them to the appropriate categories of clustering, classification, regression, as well as feature extraction and component analysis. All right, let's take a couple of examples, shall we? So one thing is, internally we use this thing, it's called workload. And what we do is we basically check workload, and if the workload is exceeding a certain value, we either migrate the session off to another machine, or we decide to expand more resources on that specific machine. Or we know when this person is going to probably run a lot more than what they're currently consuming, and hence they need a new resource. So we try to predict these actions based on the workload that the person is consuming. So how do we do this? We capture some metrics, and then we analyze them using different models. And then we apply these against the models and say, if any of these cross this particular workload threshold, and then an anomaly is generated and the ash report is provided to the ops person. We'll take a look and say, is this workload normal? Or is this going to cause any problems in the system? Or is this user really just need more resources and they're basically not allocating more resources, and hence this workload is horribly unoptimized? So these are the kind of problems that this particular machine learning model tries to solve. So the black are the actual values. The black dots are the anomalies. The light blue areas are the upper and the lower forecasting range, which is basically in blue. And the black dash line on the top is the configuration threshold, where the admin gets notified something is happening on this machine that usually does not happen, and you need to fix it. So here's an example of how we monitor workloads of sessions in the cloud. And we can predict when something is happening on a server that normally does not happen. Either the user has increased the amount of resources they allocated, or they added more CPUs, or they're using bursting, or all the users suddenly started using bursting, or there's a problem in the machine and everything is starting to slow down. So these are the things we use to predict resource allocation. Couple of other examples. So, when you start playing around with this, the most easiest way to moving to basically playing around as a developer or as a DBA is using the tools that you already know. So there's already the Oracle machine learning notebooks that are part of the autonomous database. Now, as DBAs, we're not strangers, or developers, we're not strangers to data transformation. We worked with views, materialized views, updatable materialized views. We use replication, we use Golden Gate, we use all these other methods, right? Where we've transformed data from one method to another method and built some other construct to basically extract this information. Machine learning is another tool that basically transforms data from one state to another using an algorithm to give you better insights. So in other words, these machine learning queries are no different than a materialized view created on top of some data in some way to give you a different insight that you did not have when you're looking at the base tables. Just think of it as a materialized view. Then it becomes much, much easier to understand this. Now, what is OML? OML is basically Oracle machine learning, and these are Zeppelin notebooks that are included as part of the autonomous database UI. There are a couple of examples if you don't know how to use this. And you can basically create an entire project and we can analyze it, you can visualize it. Now remember, visualizing has got nothing to do with machine learning. Visualizing is looking at your data and trying to figure out if this data needs any kind of transformation or not. And then we've always had SQL support for all of this, but at the same time, we also have people that wanted to use Python. A lot of machine learning in the machine learning category, a lot of people basically like Python. So in order for them to use Python, we've actually come up with this thing called OML for Pi. We're going to release this sometime very soon. And this is going to allow people to basically use Python along with data that basically sits inside the autonomous database. Now here's a couple of examples I put here. So if you want to find out the comparison between the purchase amounts of a particular good between men and women, grouped by income levels, where there's a significant difference in the amount purchased by men versus women, we use this function a statistical function called the t-test, and the function is stats t dep indep u. This one here. This is a statistical function, gender, amount sold, statistic, and then I've passed the attribute value as to what is observed, and I calculate something called a two-sided p-value. Now forget this term what a two-sided p-value is. A two-sided p-value in this case is what actually processes as an outcome of the statistical function. But the most interesting part is when you look at this p-value and you look at it, the value is less than 0.05. Whenever these values go below that, there's a significant difference in the amount purchased by men and women. So you notice what I've done here. I'm not a statistic expert, but I know how to use t-tests. And I've actually written a simple query that processes what has been sold to the men, what has been sold to the women, the observed values, and the two-sided p-values. And I'm using this result from the two-sided p-values to basically determine which items there's a significant difference in the amount purchased by men and women. Of course, as an exercise, please go read up as to what t-test and f-test in statistical functions are. It's a simple Google search away and you will probably get what it is. But even if you don't, understand the use case and what we used it for. When you're doing the insurance problem, remember I told you it's very important to pick the right attribute. So this is called attribute importance. And how do you do this here? Is you're using DBMS data mining to create the model. And here, what you're doing is you're creating a model called Buy Insurance AI. You're doing the attribute importance mining function. The table is this one. The case ID, the customer ID column is this. There's a column called Buy Insurance in this table that you're trying to basically put the value of should I sell this or should I not sell this? And I've created another table here called attribute import mode settings, which will basically contain the hyperparameters for this attribute importance algorithm. Once I finish creating this model, I just run this query that says the attribute name, the rank, and the value, and it basically gives me this. Now, according to this, the two most important things I need to see is how much overdrawing the money, how much overdrawing the bank accounts are, and how much money a person has in their bank are the two most important things that I need to look at in consideration when, and this is a very simple problem with 5 columns, right? If I have 50 columns, imagine I have to run this through enough data to be able to figure out what is the right thing to pick. So this is a very interesting kind of a problem, but this is called attribute importance. And here I showed you a simple example of how to create this. There are a lot of tools. As a DBA, what do I get started with? If you're an R guy, then there's RStudio. If you're a Python guy, we're going to come up with this OML for Pi, which is going to allow you to operate on pandas data frames that basically has data sitting in the backend in Oracle tables. If you're a notebook guy like me, you love Jupyter and Zeppelin notebooks, you can use this. If you use SQL Developer, there's an option, basically a plugin here called Data Miner, which will basically have all sorts of modeling and interesting data previewing. This is a thick client that sits on your machine and you can do the same kind of things that you can do in a Jupyter notebook, except some people like Jupyter notebooks, some people like thick clients sitting on your systems. So these are just different kinds of UI and apps development that you can use to progress on this. In feature engineering, remember I mentioned, so I promised you more examples of feature engineering. Instead of date of birth, which is not so interesting, I calculate age, which is interesting. Instead of address, I calculate how much do you commute, because that's more interesting versus where you stay. From the calls, I find out how many times your calls are dropped and what percentage of those calls are international calls. From a salary, I try to calculate a percent versus your peers. It means how much money do you make relative to your peers versus your salary in itself is not as interesting. And from purchases, I'm trying to find out how much do you purchase on clothing and food. This is called derived attributes. As part of feature engineering, there are 2 exercises. One is to pick the right attributes. Second is to take the existing attributes and reduce them. Remember this, if you reduce the number of attribute input to a model, the model gets built very fast and converges very well and generally performs better as compared to a model that has way more attributes that confuses the heck out of the model. And the model doesn't know which attribute is important, which attribute is not important, and tries to work on this. So this is very important to understand. In feature engineering, derived attributes are created, which take existing attributes and combine them into a single attribute. So you reduce, it's called dimensionality reduction. So when you create new derived attributes, that process is called dimensionality reduction. All right. Again, I've already gone through this attribute importance. I've put a couple of examples of code. This is how you build and test your models. This is how you split your test and training data. As you can see, it's nothing unique. How do I split this? I create a replacer view and I do a select star from something and I do a sample of 60 with a seed of 1. That's it. I put some random seed and say sample 60 rows and dump it here. And then I create another test data table as everything that is not in the training set. So you notice there's nothing complicated here. When I'm building the attributes for a model, hyperparameters for a model, I'm inserting the hyperparameters. So in this case, the algo name is decision tree. The preparation is auto. And I just insert all these specific values for that particular algorithm. And here I'm building the actual model itself. So I'll have all these details in my slides, but this is basically how simple it is to go and get started on this. Again, we spoke about how do you predict these things, and I've got a couple of slides, but this is the interesting thing. So let's come to some new stuff. First thing is, there is auto algorithm selection. As a DBA before, I had to figure all this stuff out. Now the database identifies automatically which algorithm has got the highest model quality. It also does auto feature selection. So in other words, dimensionality reduction and feature attribute importance selection is done automatically. And it also auto tunes my hyperparameters. So I don't have to do anything. All of this is taken care of by the AutoML framework, which is available with OML for Pi. What does this look like, the new interface, when this comes into autonomous database? When I have the Zeppelin notebooks, when I load any data, by default, there'll be an AutoML option. It's right here. You will automatically see importance calculated for all the attributes. You won't have to do any of this. The histograms, the importance will be automatically calculated for you. What's the advantage? First of all, if I don't know anything as a DBA or a developer about machine learning, I can start using it now without actually having to think about what's going on here. It unifies model development as well as monitoring. If something does not work, I can immediately act on it. At the same time, I can also keep developing. This is a very good way of doing CI/CD. There's a model leaderboard. In other words, which model performed well, which model did not perform well, and it will automatically compare against those. 2 new algorithms coming in. One of them is XGBoost, and the other one is MSET SPRT, which stands for Sequential Probability Ratio Test. Now forget that one. Don't care about what it is. Remember what the second one does. The first one, is very good for classification, regression, ranking. If you have any of these problems, XGBoost is very popularly available in everything, in all packages. Whether you use scikit-learn, TensorFlow, Oracle ML, it's available everywhere now. MSET SPRT is something more specific to Oracle, but this is our implementation of SPRT. And what it basically does, it does anomaly detection, and it also detects these anomalies without producing false alarms. That's important. So the quality of the algorithm in terms of how it detects false positives is much, much better as compared to the other algorithms in this category. I mentioned about the data miner UI that's part of a SQL developer. So almost there. One more thing I would like to mention before we end this session is Oracle also has this thing. It's called the Oracle Cloud Data Science Platform, which also has AutoML and feature selection and evaluation and model explanation. But this is different from OML. OML is more in the database with SQL, with Python, and it combines a couple of interfaces with the autonomous database. This is a generic platform. You can take all your open source stuff, your scikit-learn, your TensorFlow, all of this is built into this platform. So this is a platform that you can create your sessions, you can visualize this information, you can combine open source packages with Oracle packages, and you can do and build an entire machine learning project using this platform. So this is a complete platform for a much bigger machine learning project that involves not just Oracle and Oracle SQL related stuff, which is what most of us DBA developers care about. But if you have other non-Oracle stuff, like you have scikit-learn, you have Keras, you have Dask, you have TensorFlow, you want to bring in all of that here, you can do that using this particular framework, or it's called the Oracle Cloud Data Science Platform. So this is something that's been available for a couple of months. If this is interesting to you, where you belong to the other ecosystems outside and you're using it with the Oracle ecosystems, this is an interesting aspect for you. If you're a Python developer and you want to use autonomous, you can basically do the same thing using OML and OML for Py. So remember this, OML is very, very simple. It builds on top of what you as database DBAs and developers already know. It's a couple of more sequels. You need to understand how to build the model, how to play with the test and training set, how to do feature engineering, and a couple of things here and there. And that's pretty much it. So it's very easy for a migration path. If you have to move into this other stuff, and you already, this is very popular with people that are already using these other third-party open source frameworks, and they want to come into the Oracle Cloud and they want to play with all of this existing stuff. That's where this platform shines. So always remember this, the easiest way to do things is you have a ton of data that's already sitting inside the Oracle database. If you're using things like OML, you don't have to move the data. One of the most common problems people do is they basically take the data and they move it out of the database. They process something using an open source framework, and they load the data back up into the database. Now, this is okay if it's a small amount of data, but if you're pulling and putting terabytes or petabytes of data and you're starting to do all this stuff, things start getting complicated very, very quickly. So if you're an Oracle DBA or developer, your data is already in the database. It's very easy to execute SQL, where these algorithms execute directly on the data, and you don't have to move the data anywhere. You don't need twice the space. You don't have to export, import, and do all of this other stuff. That's why this is a very, very powerful proposition. And if you have not thought about how to use this, you should start using this now. All right, questions. I know this is a lot to cover in 45 minutes. I don't know. Do I have time for questions, or are we up on the hour? I think I took 35 minutes or so. Let me see. I think there's some questions in Q&A. Is there any unique algorithm to identify and catch fraudulent user operations? You can use any of these algorithms that I mentioned. There's nothing unique. It depends on what case that you have. See, one thing that you always remember, right? You won't get a straight answer for any of these problems, because the answer is it depends. It depends on what your data looks like. It depends on which area of fraudulent user operations you're looking at. But usually it will be a classification or an anomaly detection algorithm, mostly anomaly detection algorithms. So we have used ARIMA, Atom Optimizer, and a whole bunch of other stuff with anomaly detection to perform all these kind of operations before. Are you going to share the presentation content? Yes, as you can see on my screen right now, it's going to be on my slide share. So if you take a picture of my screen, that's good. Do I have anything else here? I have something in chat. Sorry, I think that's already covered. All right, let's see. Thank you for the overview. Yep. So I guess that's the whole idea behind this presentation. It's to give you an understanding. Understand these terms. Forget the algorithms. Forget how these things work. Forget the complicated terms that people use constantly. Understand a few basic terms. Understand how they come together. Understand the SQL. You already know this. It's your familiar area. Just build on top of what you already know as a DBA or a developer. You already know 80% of this. You just have to learn a couple of more things. write the SQLs, train the models, and then you'll be like, man, this stuff is so simple. I don't know what I was thinking about and why I did not bother using all of this stuff. Can you recommend some tutorials that explain ML algorithms? Which one to use for different use cases? This is a pretty big space. There's a bunch of guys that I follow on Twitter that have different GitHub links. If you could send me a message on LinkedIn or Twitter, I'm happy to send you a couple of links for tutorials to get started. One of my favorites when I got started was scikit-learn. Scikit-learn has an excellent set of tutorials by the guy who basically was responsible for building out scikit-learn, and he's uploaded most of the stuff to his thing. There's a lot of, if you're focused on image visualization, Andrej Karpathy has a good one on his Twitter feed. From time to time I see something. So there's different people in different areas that post these things. So it depends on which use case. Focus on the use case. Don't focus on the algorithms. The algorithms, you lose track because every 3 months a new algorithm comes out and it obsoletes all the previous algorithms that were already there. Are there any other statistical functions inside the Oracle database more than stats, t-test? Yes, there are actually an entire page. You know, I did not have it in this presentation, but there are a couple of other presentations that I have already done that's in my slide share, where there's an entire page from t-test, f-test, ANOVA functions. There's an entire page of statistical functions from mean, mean, median, sum, variance, any kind of statistical function you can think about. There's an implementation already in the database for it. All right, I've already answered this one. Is OML supported in 12C? No, because we started adding the support for most of this stuff in 18C and higher, because the algorithms are embedded inside the database for this. But what you could do is you could actually put data into an 18C database and run it against it and then pull data via DB links in the 12C instance. That's something that you could do. So you could create procedures that run the ML functions on the 18C database and pull the results of these values, which are also very simple SQLs, from the 12C database using simple SQLs. So you just need the results back in the 12C database. The actual algorithm implementation started around 18. We added a whole bunch around 19 and 20. All the other stuff I showed you is 20, 21, and onwards. Do I have any other questions? I think we are done here. All right, I've gone through the list of questions here.
I want to add something. Sorry for jumping again in your session. There will be a panel discussion on 8th of October at 6 p.m. Central European time. And it's about what technique to be used in different technique of machine learning to be used in different use cases. So I think that the people that are interested in this idea should join the panel discussion.
Yeah.
Registration, it's open. It's on the agenda of 8th.
Some really good machine learning.
Sorry?
I'm sorry, go ahead, Mirella. Sorry, yeah. Go ahead. I overlapped on you. Go ahead, please.
No, that was all. Check the agenda of the 8th, register for the panel discussion, and during that discussion, you will be able to ask several questions on this topic. And as far as I know, the participants of the discussion are preparing a list of tutorial and research where you can check and learn more about this topic. That was all from my side. Thank you so much, Sandesh.
There are also a couple of people presenting. There's Helly, there's Charlie Berger. I think even Brendan Tierney is part of this, right? Yes. So there's a bunch of good machine learning experts who also work on this space, who will actually have other sessions. So these sessions might also be worth following on to, because I just covered the overview because I just wanted you guys to dip your toes into this. These speakers will take it to the next level.
So thank you so much. We have to close it and jump to the other session because people are waiting already.
Thank you. Thank you so much. And you guys have a wonderful day.